Hello all, welcome to my YouTube video. So in today's video we are going to discuss about Azure Front Door services. So as part of this particular architecture, if you can see, I have included a component Azure Front Door. If I just exclude this particular service Azure Front Door, then the entire architecture I have already explained in my previous video. So I'm not gonna explain in very detailed manner here. So this video is majorly focused on Azure Front Door, how we can use it in our environment. So let me give you a very brief about this architecture, what we are supposed to do. So basically we are deploying a web application on AKS cluster. So for that basically I have created a three virtual network. The first one here is AKS VNet, the second here is ACR VNet, and third here is Agent VNet. So in each virtual network I am creating a sum of resources. So for example on Agent VNet I am creating a Azure virtual machine which we are going to use as a self-hosted agent, and in the ACR VNet I am going to host my private Azure container registry, and in the third virtual network which is AKS VNet, here I am going to create my private AKS cluster, and also I am going to install application gateway as part of this virtual network here. And we are application gateway we are going to integrate with Ingress controller as well, so we can access our application. So the link I will keep in a description box. So only Azure Front Door you cannot find on that previous video. That component I've included in my this video, so you can go ahead and check it out. So here the major focus on this video is going to Azure Front Door. So we are going to see how we can create a Azure Front Door services with the help of Terraform, and we will do a complete deployment of application, and how we can access our application with Azure Front Door. So those things we are going to majorly focus on this video. So let's start. What is Azure Front Door? So Azure Front Door is a modern cloud content delivery network service provided by Microsoft. So what is content delivery network here? A content delivery network is a distributed network of servers strategically positioned across various geographic locations to deliver web content such as images, videos, scripts, and any other static or dynamic content to user more efficiently and reliably. So maybe on this slides these particular lines it will not clear. In the next slides, as with the help of diagram I will explain you, then maybe it will be more clear to you guys. So the primary purpose of CDN is to reduce latency, improve website performance, and enhance the user experience. Azure Front Door deliver your content using Microsoft Global Edge Network with hundreds of global and local point of presence distributed around the world, close to both your enterprise and consumer end users. And the last we have here, Azure Front Door provides security features such as SSL, TLS encryption, DDoS protection, and web application firewall. So let's understand the concept of Azure Front Door with the help of one diagram here. So we are going to understand complete Azure Front Door with the help of this particular diagram. So you can see here, this is the door, or you can see a simple wall. This is called a front door. So behind the front door we have our regions where we have deployed our application. So suppose I have taken here two regions, East US region and West US region. Now you can see these particular boxes, POP, point of presence. These are nothings, these are the networks or servers which Azure Front Door is used to catch their content. So if I'll go to my previous slides, you can see here a content delivery network is a distributed network of servers positioned across various geographic locations to deliver web content to user more efficiently and reliably. So what is happening here basically? So suppose this user is requesting some content from this particular web server which is hosted in East US region. So the first thing what he will do, he will stabilize a connection to this particular region or to the particular application which is hosted on this region through a TCP protocol. Then it will get some kind of confirmation, okay, the connection is stabilized. then they will send a request like, okay, I need to fetch this amount of data. Then again it will go ahead and fetch the content from this location. So this is the user 1. Now the user 2, the actor 2 here. So suppose this actor 2 is again requesting the same content from these two regions. So what is happening here now? I will come to this terms little later, because everything is going to happen with these terms only here in Azure Front Door. So now the second user, whenever request to the content, same content from these regions, now whenever he requests to batch to S region, for example, it will not go to this location. It will go to the point of presence. These are the network servers, multiple lot of servers Microsoft deployed in a many geographic locations to cache your content. So it will go to request these nearest servers, and the content will be cached here, and it will get a response. So you can see the latency here is reduced. Now this actor has to go to all the way to this particular region where our application is running, and then it's fetching the data from this particular location. Now in this particular manner, the latency is high. Now here this user no need to go ahead to west to west or east to west region, because it automatically found the data on these servers, these point of presence, and it will get the response. If this user, whatever the data is requested, it's not cached in this network or servers or point of presence, then again he has to follow the complete protocol. Like first he has to go to the west to west, it will stabilize the connection, then it will get this acknowledgement, then it will request for the data, whatever data he need. Same process he had to follow. So that's why we use Azure Front Door, because it cache your content, so the latency will be reduced and your application performance will be high. Now let's understand these terms here: Anycast, split TCP, SSL offloading, and caching in the next slide. So caching, I've already explained, like the whatever the content any user request, if it's a cache on these point of presences, then there is no need to actor to go to this particular region and get the data from there, because if it's already cached, it will get the data from this point of presence only. Now these are the following steps can explain the following of Azure Front Door. So I have explained you very simple way. Now we will see in a technical terms how data is traveling between a point of presence to regions and from to the end user. So the first user send a request to the front end host of Azure Front Door using the web application. The front end host receive the request and evaluate the routing rules to determine which backend pool to route it to. For example, if the request is for the URL path blog, the front-end host may route it to the backend pool that hosts the blog web applications. So for example, the user want to access any kind of blogs and which is hosted on these east or west US region, then it will, for these US region we have suppose 3 servers. One is hosting videos, another one is hosting some static content, and another one backend server is hosting blog. Then the routing rule will decide, okay, I have to go to the third server because that server hosts the blog. So the routing rule is required to route the traffic to the accurate backend pool so it can get the data. Okay, so the front-end host check the cache to see if the request content is cached. So that what we discuss here. The first time it will stabilize the connection, it will get the data and cache in the point of presence. So what we are going to see here. So the front-end host check the cache to see if the requested content is cached. If the content is cached and fresh, the front-end host return to the user, and the front-end host proceed to the next step if the content is not cached or stale. So if the content is not cached at the point of presence location, then it will go to the backend server or a region where our web application is running, and it will fetch the data from there, and then it will cache the data. So the front-end host send a health probes to backend pool to check the availability and response time of the backend servers. So here the backend server is nothing, it's a web application which is hosted in a region. The health probe is a simple HTTP and HTTPS request that expect a 200 OK response from the backend server, and the user can configure the health probe frequency and timeout. So these are the configurable. Whatever the response time you have to set, you can set in the configuration. Now the front-end host select the best available backend server from the backend pool based on the proximity, health and load. And the front-end host also apply the security policies such as SSLS, TLS encryption, DDoS protection and web application firewall to the request. Then the front-end host forward the request to the selected backend server using the original URL or a modified URL based on the routing rules. For example, if the request is for the URL path /blog, then the front-end host may forward the request to the backend server. So if in our backend, as I told, there are many services, images, videos and some other content and blogs. So it will find, okay, I need to send a request to this server because for example, server 4 is hosting our blog applications. Then it will, based routing rule will decide, okay, this traffic go to the server 4, not on any other servers. That's why routing rule is very important. And whenever you configure the routing rule, you have to always keep in mind your backend pool should have HTTPS or HTTP. You have to check those things, otherwise the front door will not work, because it's totally depend on a HTTP and HTTPS protocol. The front-end host receive the response and cache it if the caching is enabled, and the response meet the caching criteria. If the compression is enabled and the response is compressible, the front-end host also compress the response. So that's how basically the entire workflow in Azure Front Door work. So there are three main components which we'll see in the coming slides: the front-end host, back-end pool and the routing. These are the main backbone of Azure Front Door, which we have to basically we have to keep a depth understanding about these three major components, because this is the components which is going to configure your Azure Front Door services. Now we will see capabilities of AFD, Azure Front Door. So these terms we have seen in the diagram slides. So what is Anycast here? So Anycast is a networking technique used to improve the scalability, resilience and performance of network services. Anycast allow multiple servers or network device to advertise the same IP address from different locations across the globe. When a client sends a request to the Anycast IP address, the request is routed to the nearest or best performing server or network device that advertise that IP servers. So whatever the IP servers Anycast, suppose one of the web application server we have configured as Anycast, then every time whenever the client send a request to Anycast IP addresses, the request is routed to the best performing server or network device which is casting that particular IP addresses. Second, we have a split TCP. So this is a very important term in Azure Front Door, like in terms of understanding how data basically travel from front door to backend, front end to backend, all these things, and between the point of presence as well. So split TCP refers to a technique used in the networking to optimize the transmission of data over long distance, high latency connections such as those encountered in a wide area network or a satellite link. So like basically split TCP is help in those scenarios where we have a high latency, like we are setting in India and our server is in US. So you can see the latency is very high. In those scenarios, split TCP work very well. So in traditional TCP, a single TCP connection is stabilized between a sender and a receiver, and this connection is used to transmit data package between the two endpoints like client and servers. In between these two, data is traveling or transmitting. However, when the connection travels a long distance network with high latency such as a transcontinental link or a satellite connection, TCP perform may degrade due to effect of latency and packet loss. So if the latency is very high, then there are chances your package or data can lost your packages which you are fetching or asking from that particular server. So split TCP address this issue by breaking a single TCP connection into two separate connections. So the first is called a control channel and another one is called a data channel. So the control channel is responsible for managing the TCP connection setup, acknowledgement and flow control mechanism. It handles the transmission of TCP control packet such as SYN, ACK and Windows update. So those packet or those transmission basically is handled by control channel. And the second channel here is data channel. So the data channel is used exclusively for transmitting data packets between the sender and receiver. It carries the actual payload of the TCP connection such as HTTP request or file transfers. So the control channel basically stabilizes the connection from between the sender and receiver, and the data channel basically carry your data your packages which you require. Third term here we have SSL offload. So SSL offload, also known as SSL termination, is a networking technique used to offload the SSL and TLS encryption and decryption process from backend servers such as web server or application server to a dedicated hardware devices or software component located at the edge of the network, means point of presence. So these are the three components of Azure Front Door. Not three, these are the main component of Azure Front Door. So the front end host. These endpoints receive a request from your user and route them to the backend pool. So this is the work of front end host. They are also responsible for caching static content and applying security policy. You can have multiple front-end hosts for different domains or subdomains of your application. Each front-end host has a unique URL that end with .azurevt.net. We will see in a demo. So I think it's clear about the front-end host. So the main purpose or the main work of front-end host is to send a request, receive a request from user and route them to a backend pool. Backend pool. These are the group of backend server that host your web application. So actual application is deployed on a backend pool. If accessible over the internet, they can be in or outside Azure. Like you can also use Azure Front Door if you have on-premise network. It's not mandatory you should have Azure cloud network itself. So you can utilize in hybrid mode as well. You can have multiple backends pool for different web application or regions. Each backend pool has a health probe that monitors the availability and response time of the backend server. So basically for Azure Front Door, you should have a network, you should have a domain name or IP address which is publicly accessible. Then in that case, you can use Azure Front Door. Next, here we have a third component, routing rules. So these are the rules that define how the requests are routed from the front-end host to the backend pool. They can be based on the criteria such as URL path, HTTP method, header, query string or cookies. So these three main components of Azure Front Door are you should have more clarity on these three terms. Major focus you should follow on routing rules, because here you have to decide if your backend is running on HTTP and you are configuring the routing rule for HTTPS. In that case, your whenever after creating the rules, you cannot access your web application because it will not redirect the traffic from HTTPS to HTTP. So you have to keep in mind whatever the backend servers is using the protocol or certificate, based on that you have to configure your routing rule. Now we will see the features of Azure Front Door. Global load balancing. So Azure Front Door intelligently distribute incoming traffic across multiple backend endpoints such as Azure Web App, API Gateway or custom origins, ensuring optimal performance and availability for user worldwide. So basically Azure Load Balancer is a global load balancer and application gateway is a regional load balancer. So Azure Front Door is helpful when you are configuring a multi region cloud architecture. In that scenario, you can use Azure Front Door. Second, content delivery network, which we already discussed. So front door leverage Microsoft's global network of edge node to catch and deliver static and dynamic content closer to end user and reducing latency and improving user experience. Next, we have SSL and TLS termination. Fourth, we have application layer security. So front door provide built-in protection against common web application threats such as DDoS attacks, SQL injection, cross-site scripting, and bot traffic, helping to safeguard application and data. Now another term we have is session affinity. So front door support session affinity means sticky sessions, ensuring that a subsequent request from the same client, you can keep in mind this word, same client, are directed to the same backend server, which is useful for maintaining a session state in stateful application. So if you enable this session affinity, then the client which is requesting, it will always request to the same backend server. It will not redirect to the another backend server if you have enabled session affinity in your environment. Next, we have a health monitoring and failover. So front door continuously monitor the health and performance of backend endpoints and automatically reroute traffic away from unhealthy endpoints to ensure high availability and reliability. So if you want a highly available of your high availability for your application, then you should use Azure Front Door. There is also a global service which is Azure Traffic Manager, that also you can use. So I will create a separate video for Azure Traffic Manager as well. Integrated analytics and monitoring. So front door provides built-in analytics and monitoring capabilities, allowing you to gain insights into traffic patterns, performance metrics, security events, and operational status. So these are the basically advantages of Azure Front Door. Now let's move to a demo here. So let me go to my Azure portal. So I'm going to explain Azure Front Door, how we can create from the Terraform. So if you can see here, this is my resource group, and under this resource group I only have 3 resources. One is SSH key, another one I have key vault and storage account. Apart from that, I don't have any services under this resource group. So let me go back to my pipeline here. So as part of this particular architecture, I'm going to use 2 pipelines. One pipeline is for just creating all the resources in the Azure cloud, and the second pipeline will be to deploy the application on the AKS. Then we will see how we are going to access that applications. So let me go back to my Azure DevOps servers. I'll go to repos. So in repos, I'm just going to explain about front door only, not all the services. If you want to see all the services, link is in description box, so you can go ahead and check it out. Let me copy that content and I will open in a Visual Studio Code, so that will be more clear. Okay, I'll create a file, demo.tf. Okay, what happened? Okay, let me do one thing. Let me clear the content of this file and I'll paste it here. So you can see here, the first block, you can see data block. So here what I'm going to do, I'm fetching the application gateway detail here, and because for Azure Front Door we need a public IP addresses. So basically with the help of data block here, I am fetching the public IP address of application gateway, so we can create Azure Front Door services. So these are the locals which I have defined here, and this is the Azure CDN profile which we are going to create. So this is a resource type Azure RIM underscore CDN underscore front door underscore profile, and this is the local name of our front door CDN profile, local name, and this is the actual name. With this name our CDN profile will be created. So you can see in a name I have used here local. If you don't want to use local, you can also use variables. So in a local dot front door profile name, so if you can see front door profile name here, I have defined it my front door. So with this name it will create, and this is the SKU. So Azure Front Door use two type of SKUs, standard and premium. So if you want to use a private endpoint in your front door, then you have to use a premium. If you don't want to use link your private endpoint, then you can use a standard SKU as well. I will keep this Terraform configuration file in GitHub, and I will mention the link as well in the description box for that. Now the second one, what I am going to do, I am going to create an endpoint. And third, we are going to create an origin group. So origin group is also must, because under origin group you are going to create a origins. Origins is nothing, it's just a backend services which you want to create or which you want to enable in Azure Front Door. And in the last, we are going to create a origin, and then finally we are going to create a route here. So in a similar way, on a same pattern, we have to create. If I just show you in Azure portal itself, I'll go to my Azure Front Door. So I don't have any front door here. I'm not going to create from portal itself. I'm going to use a Terraform just for the demonstration purpose. I'm going to see what all the steps I have shown here, like what all the things we are going to create as part of Azure Front Door. So that I'm going to show you in a GUI mode. So I have chosen custom create. Let me go back to continue to front door. I'll choose my resource group. You can see it's a global load balancer, so it is not asking for the resource group location, because whatever the location your resource group is, it will take that location by default. And as you can see, SKU side we have two, standard and premium. So the name I'll put it here, suppose demo. So if I'll go back to my BS, the first thing what we did, we have created a CDN profile here, name, resource group and SKU name. So these three things I have defined here. Next, I'll go to secret. If you have any certificates and all, you can take it from add it from here from Azure keyword. I don't have any. Next thing you can see here, endpoint. So if I'll go back to my configuration here, so second thing what we are doing after CDN profile, we are going to create an endpoint here. Let me go back to my portal. So I'll click on add an endpoint. So I'll keep here name and point 1, and I'll click on add. So after endpoint, what we have to do, we have to create a route. So if I'll go back to my configuration here, you can see after endpoint I'm creating a origin group, origin, then finally route, because these origin group and origin is part of the route. So if I'll go back to my portal here, so if I go to here add a route, you can see I'll give you a name here for route 1. You can see now I have to add here origin group. I don't have any origin group, so I have to create a new origin group as part of to create a route. So I'll give you O1. Now you have to create a origin. So similar way in a Terraform configuration, I'm creating after endpoint I'm creating a origin group because it is required. Then I'm creating a origin, and then finally I'm going to create a my route. So that's what I want to just show you. This is nothing, a simple configuration you can find easily on a Terraform configuration page. If you search for Azure application, Azure Front Door with Terraform, you can easily find all the configurations details in a Terraform documentation page itself. So I'm going to cancel this. So now I'm going to run my pipeline here. If I'll go to my pipeline, so these two pipelines I'm going to run here, infra as a code and e-tickets -main. So let me run the first pipeline. I'll select run pipeline. I'll choose my stages. So I need VNet, VM, ACR, DB, App Gateway, AKS, and Front Door. So all these services I need to create. So this creation is gonna take couple of minutes, mostly 20 to 25 minutes. So meantime, in that time, I will pause my video. Once the configuration is completed, then I'll come back and show you. So now you can see my pipeline execution is completed. So it's created all the resources: VNet, VM, ACR, database, application gateway, AKS, and front door. So let's verify. I'll go to my resource group. So you can see it's created all the resources for me. So let me go to front door now. So I'll go to front door manager here. So let me take the host name, sorry, domain name here. So you can see it's coming page not found. Let me, because we have not deployed any application yet. If I go back to my application gateway, if I take the public IP address of application gateway here, because this is the backend which we have used. So this is the front end IP address. You can see 502 bad gateway, because this application gateway still it's not pointing to the AKS, because for Azure Front Door this is the backend, and for application gateway AKS is the backend. So let's deploy the application. So let me go back to my pipeline. I'll go to my application e-tickets -main. So it will take 2 to 3 minutes to complete this pipeline. So we can see some content on our application gateway. Once you deploy, create Azure Front Door, you have to wait couple of minutes to get a response from the backend. So ideally, we should get 502 bad gateway in the Azure Front Door URL as well, but we will wait couple of minutes. So start building our Docker image. Meantime, it's running. Let me go to Azure Front Door. I'll explain a few things on Front Door as well. So as we discussed, there are three main components of Front Door. The first one was front end host, second was backend pool, and third one was root. So let's verify it. So this is the front end host URL which we are going to use, or the end user is going to use to access the application. Now you can see, if I go to my front door manager, you can see we have here this root column, and this root is a part of endpoint. So let me go back here and edit the route here. So under this route you can see this is the domain name which we are going to use to access our application. And accepted protocol, I have chosen here HTTP and HTTPS, and this is the origin group, and the forwarding protocol is HTTP only because I don't have any HTTPS backend. If you see, this application gateway is also running on a HTTP protocol. And if I go back to my origin group, let me edit the origin group as well. So you can see this is the host name or the IP address of our application gateway. So if I reconfirm it, is 104.211. So this is the origin, which is a backend pool for our Azure Front Door. And if I'll choose here protocol HTTPS, ideally it should be okay. Let me edit origin host name as well. So you can see here one thing here, I have not checked this enable the validation certificate subject name validation. If you are using HTTPS, then you should check this box because it will validate the certificate. And let me close this one. Let me refresh my application gateway. So you can see I got the content of my application here. This is a sample e-ticket applications. Let me go back and refresh my Azure Front Door as well. So we'll wait couple of minutes. Let me take the domain name again. So we'll wait couple of minutes because application gateway take couple of minutes to basically listen the application from the backend pool. So we'll wait couple of minutes. Now you can see after waiting couple of minutes, we get the response from the Azure Front Door. This is the, if you can see, this is the domain which is .azurefd.net. So it means a front door services it's using. Let me go to my front door profile. One more thing I just want to show you, because here we are using the backend pool as a HTTP protocol, and if you can see, it's direct to the HTTPS. If I'll check the URL, okay, see you can see HTTPS. This is happening because if I'll go to my route here, front door manager. So in simple ways, if you have a backend as a HTTPS protocol, then on a similar way you have to configure your route, so it will redirect or it will access the HTTPS protocol. Because your backend is running on HTTPS, you cannot run your application with HTTP in front door. So let me edit the route here. So accepted protocol HTTP only, here you can see, and forwarding protocol HTTP only, because from this protocol it is forwarding the traffic to the backend pool. That's why we have used an HTTP only. So I hope you get some clarity on Azure Front Door, how it works basically, and the link of my previous video I'll keep in the description box, so you can go ahead and watch out, and you will get more clarity about the pipeline which we have used here. So like all the stages, BNet and all, so all the stages you can see. So that's all for today. See you in next video. Thank you so much.